and I'm really pleased to introduce Martin from BT, and he's going to be talking about adaptive security for cloud-native environments. So, Martin, here's the magic clicker, and it's all yours.
Let's see if I can work with it. I will do. Okay, thanks. Thanks for giving me the chance to present. Hello, everyone. Good morning. So, what I want to talk about is how does security need to change in a cloud-native environment, which is an environment where cloud is the only thing you have. And, well, why the cloud is here to stay. So we shouldn't think cloud will go away. At least Gartner says this. And I found this quote quite interesting, because how many of you remember times when we had no internet policies or strict rules who can get access to the internet? Yay. So remember, this is a long time ago. Who of you has this now? No one. So, and the same will be here. So we need to make sure that we know what to do if we are in a cloud environment. And the second thing Gartner says is it's moving to the cloud first and then cloud only. And that changes a lot of things. That means I think the usage of the cloud will change. So we will, today, mostly we look into lift and shift. We have an existing application, we move it to the cloud. And in the clouds workshop, many of these controls are looking at similar things. So I have controls now on my premises. How do I need to change those in the environment in the cloud? But this will change to a cloud-native environment where the only thing you have and your developers have is the cloud. So that means the way we develop, deploy, and manage these environments and applications will change. And sorry, I forgot to say this. So what I'm talking about is not SaaS, like Office 365, Salesforce, and so on, but running applications you write or your people write in the cloud. I think this means the current best practices we have for securing environments may become anti-patterns because they do no longer fit. And I want to talk about a few of them where I think we need to change our mindset and approaches. So we need to adapt our security and be as agile as these things are to still protect our business, because that's what we are here for. We need to protect our business. So why cloud native? What is cloud native? Cloud native means you try to run applications as fast as possible, and this is the business goal these things have. You want to reduce the cost by taking real advantage of these cloud things like scaling up and scaling down and moving things and so on. You want to increase the speed. So the time between you need a new feature on your application and its life should be as small as possible. So the aim is something like if you recognize that there's a bug in the code and the developer looks at it and says, okay, I need to change these 3 lines of code until its life on the environment should be as short as possible. And that is the risk reduction that is mentioned here. It's not security risk reduction, it's the risk of losing money by taking too long to change things. So what are these characteristics I'm referring to? It influences people, process, and technology, and this is another reason why I think it's so important that we as security think of it. One of the buzzwords, and apologies for using them, but I will get into it, what I think that is in a minute. DevOps, which is a change in culture in how IT works. The processes of developing applications with continuous integration and continuous delivery is considerably different from the approach we've done now. And that is the one that allows you to do these fixes very fast thing. And second, the application architectures change to things like microservices and containers, which are in some way the requirement to use platform as a service services and cloud providers. So what is it? So DevOps is a cultural change. It tries to bridge the gap between developers on the one hand, writing code, not caring how to run it, throwing over the fence to someone in production who then has to figure out how to do it and run it. So there's this quote from, I think it's the CTO from Amazon saying, you ship it, you run it. So a single team, if I write the application, I'm the one responsible for the application also in production. Then there's this small teams, it's called 2 pizza teams. I guess this is an American thing because, I mean, a team of 2 European pizzas would mean 2 people, at least if I'm involved. So probably it's larger ones, but the idea is You have small teams that, independent of each other, build small parts of applications. And that can be as much as saying, and in this team, you can decide what program language, what framework, what tools you want to use. It does not mean cowboy coding. I'm sitting here writing something and just do it in production. And it's not changing in production, hacking in production, but it's bringing these teams together in a single team responsible for these things, which is, as I said, mostly a cultural change. And we need to be part of that. So what is continuous integration and delivery? So in the past, we had things like, I write a piece of code, I commit it, then now I have a release plan, and after a few months, we try to bring it all together, then the nightmare begins to make it all work, and then we have the nightmare deploying it, all hands on deck, 3 days work, so nightmare thing. No, we try to, as soon as a developer checks in code, the complete software gets built and tested. Unit tested, functional tested. That means if there's a bug in it or something breaks, you find out immediately. So these builds and commits, the idea is to do this 10 times a day, 20 times a day, whatever. And then produce a deployable software with each of these builds. So it's not only, okay, it runs on my machine, it's something that we could deploy in production. And the continuous deployment, the delivery thing, this can be done in an automated fashion. We can, with a click of a button, basically the developer says commit into the version control system, and I don't know, 10, 15 minutes later, this code runs in production because it's completely automated. That's the idea. And that is the speed thing that helps you. Because it's not only for bug fixes, also if someone from the business has a good idea and says, hey, we should do this thing to our web application, and then much more customers will buy it, yeah, you can do that. And then you can have it in a day, which is a business advantage. Right? All these things also change the way we build these applications. So in the past, applications were big monoliths. I have a big web application on my web application server talking to a big database, and that's it. And all the different functionalities are within this application. Basically, maybe something, method calls between different objects in my code. Now, all of these things are torn apart, and moved into single microservices. So each service does a single thing, and it's an atomic piece. And these are deployed and developed independently. Remember the 2 pizza team thing. So maybe one service is written in Java, doing the login and the session management, and something else doing account lookup is written in Golang, and the third one is using Node.js, whatever. And these things run on containers that are short-lived. So I've seen a statistic that on average, a resource of this kind runs for roughly 2 hours. And then it's either torn down or scaled up or changed or whatever. Important part here, which also has an influence on what this means for the security, is something concept called infrastructure as code. So all these changes we then need to the infrastructure are described in templates, and if it's Ansible, you call it playbooks, so in code that is integrated into version control. That means also this continuous integration applies to changes to the infrastructure. If I say I need additional network communications between different parts of my application, I change part of, if it's Amazon Web Services, it would be something like a CloudFormation template. I just change a few lines of code in a JSON file. I check that in, and then this whole cycle starts, and it gets deployed. That's the idea. And then you may have come across this meme of pet versus kettle. I think the guy who invented it did it because it allows you to put a cute pet picture on an InfoSec slide. And second, I think he didn't understand anything about cattle because my sister-in-law has cattle and she treats each of them. She doesn't buy a new one if one gets ill, so that's stupid. But you get the idea. So in the past, we had these, we have a single server. This, I know it's this server. It's the mail server. And I will treat it and tweak it. And if it has a performance problem, we look at it and we try to improve this. And now with cloud environments, I may have automatic scaling to say if my load on the existing web service increased beyond 25%, automatically I will spin up 10 other ones, which gets randomly assigned names because I don't care. And if the load goes down, 20 minutes later, I will turn them down again. And so it's a scaling out rather than scaling up. And if a server starts to misbehave, I simply turn it down and replace it by something else. So when I first started to look into these things, I got, oh, this sounds scary from a security point of view. Because it seems to contradict what we used to do all the time. So usually for good reason, we want to have a careful security planning. We want to do an upfront design and a threat model. But if you have a small team just doing a small change in an agile way for 2 weeks, there will be no threat model or nobody who can help you before that. I want to have an approved set of these operating systems, these applications, these are the languages you can use. If the team is free to use whatever language or tool set they think is fit for purpose, I can't do that any longer. I want to have a security approval and handover into production. Yeah, but if that's all done somehow, somewhere, that sounds scary, doesn't it? I want to have segregation of duties. The ISO norm is full of that. There's several lists of controls. If I have a DevOps team with developers looking at production, I know a lot of environments where people say, oh, developers must not have any access to the production environment. And I want to have a clear handover point of view. And there's a good reason, because I want to prevent fraud, right? And I usually want to have a static change management. So we, as security, say, hey, a change advisory board is a good thing, because it gives me an idea what is going to happen in the production. I can plan not only the release cycles, I can plan, say, okay, if the new software is going live in 4 weeks, I can schedule a pen test for 2 weeks from now. If the change can happen every time, we can't do that any longer, right? So, and network security also, I don't know how many of you like the idea that a developer who sees the necessity to change network security controls can do that by changing a line of code and then have it deployed without you approving it. Sounds strange, right? And we want to avoid changing firewall rule sets, because firewall rule sets need to be audited and we need to be clear what it is. So it looks like we have an issue, right? But I think we can bridge this gap. So that's, from my point of view, good news. Well, that's by moving security to the left and up. So today, most of us look into these. Not sure where I find this. Here. We are usually talking about infrastructure and the production environment. We're not so much concerned with development, and most of us do not talk about applications. For a cloud-native environment, this needs to change for several reasons. One of them being, if you look at a platform as a service environment, you have only little influence here on the infrastructure, because that's what the cloud service provider does, right? So we need to see how we can address all these security needs early in the life cycle and more on an application level than on an infrastructure production level. That's my convention. So how can we do this? We need to integrate security also in this DevOps. So this typical gap between developers on the one hand, operating people on the other hand, exists with security as well. In many organizations, security is the other guys. Nobody loves them. Everyone goes away if you go to the coffee machine. So we need to change that. This is a cultural change, and it's a cultural change for us, not for the others. And I think the way to go is to take an approach of show, don't tell. So, which means the security people should be part of these development teams, at least part-time, to understand what are they doing. And for example, if one of these teams decides, there's this new interesting toolings, I want to use that, let's try this. If I'm part of that team, I can say, okay, you look into it if it does what you think functionally. At the same time, I will look into it, what the security implications are. And then maybe I can give you some security solution already during the development. And I think the cultural change we need is to overcome this requester-approval relationship. It's sometimes not really healthy. So we say, tell me what you want to do, and I will tell you if this is okay or not. That's not sufficient anymore in this environment. We need to be part of the developers, because otherwise we will be obsolete, because we are too late in changing anything if you just start say, hey, before you go live, do anything. That can be tricky, and I think it's something, it's a change for everyone, but if you look it up on the DevOps thing, this was also a big cultural change for everyone, so it can be done for us as well. This continuous delivery thing, in my mind, is a real advantage for us, because we can do security checks already during testing. And if you are in a platform as a service environment where you can't do security on the platform, you need to do more in the application. If you have more in the application, you can write security checks in the testing that get tested during this check-in. So for example, if you say, I want to have encryption and want to use certificates, and I of course want to make sure that there's a check if the certificate is still valid or not. That's easy testable. You can do this as part of an integration test. And you need to, of course, this requires a lot of careful planning, because things like penetration tests still are useful, but you can't do them in these automated fashion because it should be fast. So you don't want to spend hours. But if you do regular pen testing independent of this pipeline, you can still feed the results back into and say, if I find a problem that says people tend to, I don't know, forget about input validation, it's fairly easy to integrate a test into this to test during each check-in if input validation is in place or not. And one of the things I like about infrastructure as code is if I have code that describes how the infrastructure looks like, I have an overview of the assets. I know what's running in production. I know what kind of tools I have. And by the way, the nice guys from Black Duck Software can integrate in all these things. So you could use a tool like this to get an overview of not only about what versions of OpenSSL am I using, but having these integrated pipeline where I can check things fast. I can also very fast check what happens if I replace OpenSSL version XYZ by ZYX, right? So, and an interesting piece here is we usually had very static security controls, network controls. If I say I want to have a security device in the cloud, which is one of the things you will learn about in the cloud workshop, then this needs to scale as well. If my application environment can scale from 2 servers to 100 servers in a minute, it would be a problem if the firewall in between can't handle more than 10 devices. So this needs to be this needs to scale as well. And then a change in approach, which I find really interesting, is stop patching, start replacing. So I don't patch a live system. If I need to patch something because I need a different version of something, okay, I produce a new container with a new version, and I bring that up and shut the other one down. That also helps you against configuration drift. So you don't need to fear that someone changes anything on a system and you don't know what state it is in. An important part really in this case is to look into microsegmentation and east-west firewalls. If you have these microservices that can be used independently but talk to each other, you need to have a clear understanding of where they are in between. And this is from a technology point of view, one of the hardest things. Get an overview of which microservices exist and which services call each other and why. And is this a good thing? A thing I didn't mention before, which is also coming from this DevOps piece, is there's much more monitoring of the applications because the developers want to know, how does my application behave? Do I need to spin up more servers because the performance suffers and so on? You can't tap into this and get security information because what it does in some way is it gives you a baseline of normal behavior. If I know that normally these 10 servers talk to each other and users usually have this way of interacting with the application because that's what I see in the monitoring, and all of a sudden one user or one system starts to behave totally different, that might be an interesting thing to look at why that is from a security point of view, because it could be an attack. So but still the basics remain the same. So you still want to have the typical things you want to have. In fact, there are some things that can be done easier with containers. So for example, if you have these kind of, I deploy automatically via tooling, and nobody ever needs to connect to the box to check something, then I don't need port 22 on the box. There's no need to ever SSH into a production system. So remove it. That's good. And again, you want to have all these things already in the beginning in the development, because the developers need to know how the behavior in the production will be. And that's getting easier with these containers. If I know this is the way a container looks like, then I can easily tell the developer who can run the same container on his local development machine, this is the way the application will look like in production. And very important, use the logging capabilities to get visibility on the application level, like I said before, but also to integrate this into your SIEM, data lake, security operations. And this is very important and will increase the number of data points you need to collect, because as I said, the containers are short-lived and may change at every point in time. So you need to have all this context information on top, because if I later do some hunting and find out, here was at this point in time, this machine with the IP address 10.1.1.1, talking to this one, I want to know what this is. If this machine may no longer exist, or this IP address may exist, but may do something completely different now, because that was 10 days before. So this is really, you need to make sure that you have all the logging in place, because otherwise you will be really blind. So to sum up, I think changes in security can actually improve the security posture we have. So there's, from my point of view, no need to be scared of working in such a cloud-native environment. If you have a close collaboration between security, developers, and operations guys, we can find bugs very early, and we can address security issues very early, and we all know it's less costly as early as possible if we can find and fix a bug. Automation reduces human error and makes patching much easier. Yes, of course, and I think in the cloud workshop it was mentioned again, this is a juicy target for an attacker. So one of the things you definitely want to do is to look at the security of your development pipeline. Because not only these development pipeline things with continuous integration tools and continuous deployment tools, guess what? All these are cloud services as well. So it's fairly easy to set up something where you host your version control on GitHub, have Circle CI for continuous integration, which is a cloud service, which talks to Docker Hub to produce the Docker containers, which then gets picked up by a CloudFormation template on Amazon Web Services to deploy it. And that's another part of the piece we need to address then. How do we want to do this? Because it's like for many other things. If you look at tutorials, how these things can be done on the internet, yeah, they describe how it can be done easily, but not how it can be done securely. So there are usually things like, okay, just use your root account and give the integration piece full access to your GitHub repository, and so on. Yeah? So you want to look into these things as well. This is really important to make sure that you get these benefits. But again, having automation and these kind of things, if they are secure, it gives you a complete audit trail and a full logging. And that's something, then in which cases do you need this segregation of duties? If you are not really sure who's doing what and when, if you have this, you have a complete trail of whatever changed when in the environment. And wouldn't that be great? So that's what I wanted to talk about. Thanks for listening to me. Questions, comments? Otherwise, I gave you back a few minutes because he hasn't still waved his hand that I have 5 minutes, so obviously there's more time. If you want to touch him with me, have a look at these. Happy to take any questions, comments.
Thank you very
much. I have one question. You mentioned before that security team can work with the developers also part-time. What do you think of some company have the approach of having security champions in various teams, like in some developer team you may have like a security champion, so he works there, but he talks with you and knows the problem, and you make them aware of the security issues, and you will report in the rest of the team.
I think this is the way to go, because, and I forgot to mention that, thanks for bringing it up, a typical security team is not that big to have security people in every development team. So we want to make sure that the developers understand what the security pieces are. Again, we all know if a secure way is the easy way, people will use the easy way, will use the secure way. So if we can explain these things and the tests and move them into the development teams, if a developer understands that it makes sense to write a security test case for his software, great. Security of the software is better, and he's more happy because he knows what he's doing. And so yes, of course, we should have security champions in the development teams and talk to these as often as possible. Of course, yeah.
Most organizations tend to use external penetration testing resource.
Yes.
As part of this process of continuously monitoring, working with dev and testing at various stages of the release, in your experience, does it tend to increase the costs of external pen testing?
So I didn't completely understand if I think it replaces it, or?
Well, from my experience, it does increase cost of penetration testing, because at various stages throughout the development process, you're having to carry out penetration testing to find those early wins and areas and issues that need to be addressed, as opposed to the traditional approach, which would wait until everything's functionally developed and have a test target and then test. Do you agree?
I would agree that it changes, yeah. I think it was also mentioned yesterday by Chris from Black Duck Software. If you look at the real hard vulnerabilities, they are not found by automatic testing. They are found by pen testers or security researchers. So I think it's not that we don't need any pen testers anymore, but we should make sure that the result of a pen test, which still makes sense on a production or whatever environment, the lessons learned are included in the application development. So I think penetration testers as well have to be more sophisticated, because the time where you run just Nmap and Nessus and then you say, here's a report of 50 pages, that would be a way. But if a creative pen tester finds, and that's a good thing for my mind, but if an attacker finds an interesting way how to bypass session management between your containers and your microservices, that's not something any of these tools will find. But the result should be, what tests can we write, either unit tests or functional tests, in our automated pipeline to make sure that this problem doesn't happen again. Because that's what I find so frustrating sometimes with penetration tests, is the same things come up again and again and again. And if we can improve that, then I think we are better off.
Excellent, right, so we're going to finish now. Thank you very much. Please join me in thanking Martin again.
Thanks for your attention.